This is Clyde Hughley as we prepare for Module 5. We're looking to see if the data that we have is showing if a 15-minute coaching session has any significant effect on bowling scores. Now, we're going to assume our assumptions for performing this paired t-test have been met and that there is a significant effect on bowling scores. That is our hypothesis. So I'll open up our data in our SPSS, and it opens up there and it shows our data. And just in case we're having similar errors before, I'll go to new share, and there's our screen right here. And our screen is showing us with the data view. We have game one, that what the kids had before they had their 15-minute session, and game two, what was there after their 15-minute session. So we have our scores, they're here and they're paired. So what we want to know are the differences normally distributed as we see them there. So what we're going to do is create a transform, a menu under transform. So what I'm going to do is complete variable, and my target variable is the difference between what happened in game two after their 15-minute session minus what happened in game one before that 15-minute session. And so I click OK, and that's executing, that's there. And we will do this. And just in case, there you see our screen. It shows our game one, game two, and the difference between the scores that are there. So what we have here are the data that shows from our beginning of our test of what's going on. So what we want to do is to see if this has a normal distribution or not. So what we need to do is analyze our statistics. And what we're going to do is go to Analyze, Descriptive Statistics, go down to Explore. Now, what I want to do is move my difference here to my dependent list. I have that there. Once I've done that, what I want to do now is do a histogram plot. So I'm going to plots, histogram. I'm going to not worry about that, but I do want to have normality of plots that's there. And I'm going to hit continue. Okay. And that's executed there. And what we have here is that we have our sum of it all. We have 20 students that were involved, and everyone's scores are there. Our descriptives of what happened, but this is what we want to look at, our histogram. Okay. First of all, before I say that, we want to look at the results of our Shapiro-Wilks test, and it shows a significant mean of 0.337. Now, that's larger than 0.05, and it tells us that the data is normally distributed. Okay, so we look at our histogram and we can see, scroll down a little bit, that it does look kind of normal. There is a normal distribution. Therefore, we can use this paired samples t-test to analyze our results. Okay, we see this again. That shows that right there is kind of normal, the flow that's there, and that's what it said on our Shapiro-Wilks test of normality. So now we're going to do this to analyze to see if what comes out of the paired samples t-test. I go to Analyze again, Compare Means, scroll down there. Okay, and then we do Paired Samples t-test. I've done that. Now I'm going to use my two variables. My first variable is going to be game two. I want to see if the game two scores as related to our second variable, the game one scores have normal distributions in the sense of what we find there. Okay. Now I'm going to click OK. as I look at this, I look at my paired sample statistics, scroll down just a little bit. Whoops, too much. Just a little bit. And I have my paired samples t-test as you go right down here. And I have my scores that we see. In our paired sample statistics, we see there is a 94-95 mean from game 2 compared to game 1 of 90. The numbers are there. Standard deviation, not much difference between the standard deviation nor not much difference between the standard area of error of mean. So what I do now is go to my paired samples test, and we saw our value of t is 1.685 with that differentiation that's there of 19 with a two-tailed significance of mean of 0.108. 0.108 is greater than 0.05. So that's for we have to reject our hypothesis. Our hypothesis is that there was a significant effect on bowling scores. But our hypothesis is rejected because we see our two-tailed significance of mean is greater than 0.05, which tells us there is no significant difference. This is Clyde Hughley. Thank you very much.